I want to talk a little bit about direct and inverse variation. So I'll do direct variation on the left over here, and then I'll do inverse variation, or two variables that vary inversely on the right-hand side over here. So a very simple definition for two variables that vary directly would be something like this. Y, it varies directly with x if y is equal to some constant with x. So we could rewrite this in kind of English as y varies directly with x. And if this constant seems strange to you, just remember this could be literally any constant number. So let me give you a bunch of examples that would also be, or I guess particular examples of y varying directly with x. You could have y is equal to x, because in this situation the constant is 1. We didn't even write it. We could write y is equal to 1x, then k is 1. We could write y is equal to 2x. We could write y is equal to 1/2 x. We could write y is equal to negative 2x. We are still varying directly. We could have y is equal to negative 1/2 x. We could have y is equal to pi times x. We could have y is equal to negative pi times x. I don't want to beat a dead horse now. I think you get the point. Any constant times x. We are varying directly. And to understand this maybe a little bit more tangibly, let's think about what happens, and let's pick one of these scenarios. I'll take a positive version and a negative version, just because it might not be completely intuitive. So let's take the version of y is equal to 2x, and let's explore why we say they vary directly with each other. So let's pick a couple of values for x and a couple of and see what the resulting y value would have to be. So if x is equal to 1, then y is 2 times 1, or is 2. If x is equal to 2, then y is 2 times 2, which is going to be equal to 4. So when we doubled x, when we went from 1 to 2, so we doubled x, the same thing happened to y. We doubled y. So that's what it means when something varies directly. If we scale x up by a certain amount, we're going to scale up y by the same amount. If we scale down y by x by some amount, we would scale down y by the same amount. And just to show you it works with all of these, let's try the situation with y is equal to negative 2x. I'll do it in magenta. Y is equal to negative, or let me do a new example that I haven't even written here. Let's try y is equal to negative 3x. So once again, let me do my x and my y. When x is equal to 1, y is equal to negative 3 times 1, which is negative 3. When x is equal to 2, so negative 3 times 2 is negative 6. So notice, we multiplied, so if we scaled, let me do that in that same green color. If we scale up x by 2, it's a different green color, but it serves the purpose, we're also scaling up y by 2. To go from 1 to 2, you multiply by 2. To go from negative 3 to negative 6, you're also multiplying by 2. So we grew by the same scaling factor. And if you wanted to go the other way, let's say if we went, now let's do inverse variation. So if I did it with y's and x's, this would be y is equal to some constant times 1 over x. So instead of being some constant times x, it's some constant times 1 over x. So let me show you a bunch of examples. It could be y is equal to 1 over x. It could be y is equal to 2 times 1 over x, which is clearly the same thing as 2 over x. It could be y is equal to 1/3 times 1 over x, which is the same thing as 1 over 3x. It could be y is equal to negative 2 over x. And let's explore this, the inverse variation, the same way that we explored the direct variation. So let's pick, let's pick y is equal to 2 over x. Y is equal to 2 over x. And let me do that same table over here. So I have my table, I have my x values and my y values. If x is 1, y is 2. If x is 2, then 2 divided by 2 is 1. So if you multiply x by 2, if you scale it up by a factor of 2, what happens to y? Y gets scaled down by a factor of 2. You're dividing by 2 now. Notice the difference. Here, however we scaled x, we scaled up y by the same amount. Now, if we scale up x by a factor, when we have inverse variation, we're scaling down y by that same. So that's where the inverse is coming from. And we could go the other way if we made x is equal to 1/2. So if we were to scale down, x, we're going to see that it's going to scale up y, because 2 divided by 1/2 is 4. So here we are scaling up y. So they're going to do the opposite things. They vary inversely. And you could try it with the negative version of it as well. So here we're multiplying by 2. And once again, it's not always neatly written for you like this. It can be rearranged in a bunch of different ways, but it would still be inverse variation as long as they're algebraically equivalent.